Okay, so let's do this. What we will want to do is a little color drizzle, color collage, and so we will, what I usually do is define a size variable and and size the canvas. So just let me show you that. If I do that, then the canvas will be 400 by 400 pixels, but I want to set the canvas to, actually I will give the y variable here the window height and the x the window width. And what I will do now is I take size x, size y, and what that will do is that we have the whole the whole window as our canvas. Okay, so I'm sorry. Yeah, let's do that. Okay, and I want to have it a bit darker, so I like it to be like a nice gray. I like that actually. Maybe, oh sorry, I like to take primes. Why not? Oh, this is good. So yeah, what do we want to do? We want to let particles start randomly in the canvas, and each particle shall have a random color and perform a random walk, right? So what I will do is I will define a number on how many particles I want to create, and yeah, let's create these particles. And for that I will write a little function where I take a number and create an empty array, and yeah, go over some for loop, which is n long, right? And perform something, which is I want to push an element to this new pos array, and this array shall be this new element shall be yeah, we want to actually just choose a random position in the canvas, which we can do like that. Push it to the array and return the array, right? So we create an empty array here. We go through a for loop, which is n long, the number n long, and we push a random position to this new pos array, return this array. And what we will do now is define a pos array here, which I initialize with my function, and this n of course, yeah, is this n right here, and I give that to this function init pos, which is this one. Okay, so now we have our positions, which are random positions. Let's draw them and see what happens. So what I do is I say pause and for each, and I take a particle, call it particle, and draw a circle for that particle. And let's give it a radius of 10, and yeah, so this is what we will see, right? And if I do this again and again, we will always get new positions, and they will always be random in the canvas. So that's very nice. But another thing I want to do, I want to give them random colors. So I create a little function, which is get random color, and I want to return a color where I choose each of the R, G, and B values randomly. Here we have to round so that, I think we have to round so that we get an integer for the color value, right? So what we'll do is for each circle we we fill with an M, with a random color, right? Okay, so this looks nice already. So what we can see here is that the color is always changing, right? So in every of the loop, the draw, every time the draw function gets executed, we'll always create new random colors. So that is nice. Yeah, it's for itself is a nice thing, but I do not want to do that. I want to give every of the particle one color and leave it to the color for the whole runtime, right? So another thing we will create here is a color array, and we will initialize this very similar as the position array, which is and I just renamed them. So this array. So we do the same thing. We create a new empty array, and we loop over a k for n times, right? And but this time we won't push a random position, but we will push a random color, right? So let's do that. Right, so now we push a random color, and yeah, so now we will not choose the random color. Actually, I leave this in comments, because maybe we will like to play around with that in the future. But here now I will actually choose the color, and now we should use this this little functionality of the for each. The array method for each, and many of the array methods have this this property that we can kind of loop over the array of the elements of the array, in this case the pos array, and we can work with two things here, which is one is the element of the array, and here the index of where this element is located in the array. So that is very helpful, because now we can work with this index, which is this is the index of this array, and we want to take the color with that index. So the color with that index is the color of that particle, right? So if we do that, I have not yet initialized the colors. So let's do that, and yes, so that looks better, at least more as I want to do it here, which is each particle has one fixed color, which we initialized in the beginning. Of course, if we do this again and again, we will always get a new configuration of the positions and of the colors as well. What I would like to do now is move these points, right? So let's do that. For that I will again run a for each method. Okay, so yes, for that I will actually, what I will do is I will choose a random angle, right? Choose a random angle, and I will add always the same step length. Will actually a step size. I have to define that here. Later we will all make that dependent on on the canvas size, so it will be applicable to any kind of window size. So every value here will depend on the canvas size, so it will be kind of the same thing if you open it on a phone or on a big screen. So it should always depend on that kind of size, so it will have a similar functional and visual appearance, right? So but I will do that later. For now, for this now I want to I want to let the particles move. So for that I will choose a random angle. What I will do now is I will not sure if this works. Let's try that out. I will add on particle X, I will add the step size times the cosinus of the angle, and so what we can see here, that looks very nice as well. Actually looks very nice. So now all the particles just randomly move left, right, because we add on the x coordinate of the particles, we add a random step, basically. So step size is the absolute value of the step size, of the total step size, which like it will be the absolute value if I add the y, the addition of the y as well. In that case, it's reduced a bit by the cosinus. So maybe I draw that down another time, but for now it's fine. So now we have random walks by the particles, and it looks funny, definitely. And now what we will want to do is, we do not always want to draw the background, because it will always draw on top of our particles. We want to see them, what they draw, right? That looks much better. Okay, so that looks really nice. That is what I wanted to do. So you see how quick we can do stuff here, so that's nice. I will try out something else. I will actually, here you see that in the circles they have a stroke, they have a thin stroke. I want to turn that stroke off, so let's do that just in the setup. So now we have this. This looks nice. Okay, that looks very nice. What I want to do now is I want to make everything dependent now on the canvas size, basically. So let's do that. Which in that case, let's try it out. We take maximum of size X and size Y, and okay, that's a bit too much, right? So we around that because we want to multiply that with some factor, maybe within half. No, that's not bad. No, it's a bit too much still, so let's make it a 2 by 5. Maybe that's better. Let's leave that for now. Okay, so now we have that, so we don't need this number here anymore. Let's actually just log that value, so we can have a feeling of how many these are. So yeah, it's much more than before. We had 100 before. Actually, let's try it out with, I think that's fine. Okay, so that's fine. What else can we make dependent on? The step size, of course. The step size could be, we do not have to round it actually. we can again, actually we can take, this time we take the minimum of the two, of the width and the height of the, and then we make it 100 of that. Actually, what I get another idea right now. Let's define the diameter of these circles. That has to be dependent on that as well. So we had a 10, so that was yeah, we could kind of make it 10th of n. That seems to be fine. And now we actually yeah, we want to set the step size, which should actually be the diameter. That will result that in the circles actually we have to adjust that. Of course, we have to draw circles with the correct diameter. Okay, so what we get now, I mean, it's not easy to see that for now, but the circles actually, they move always a circle further, right? So every circle, the next step moves a circle further. Actually, I think the circles are a bit too big, so I think the diameter is a little bit too big here. Let's make it a bit smaller, so that's a much more peaceful appearance already. Okay, so we do not need a step size here anymore. Can delete that. Okay. I think this is fine too. Okay, so nice. What else can we do? Actually, I think it's a bit too. I'm not sure. Maybe they move a bit too quick. I want to present you a little thing I usually do, which is I actually kind of outsource functionality of drawing and moving. So any drawing aspect I will put here, and any moving aspect I will put here. Okay. So what I have done now is the draw method is the one which gets executed again and again, right? So here we call the draw everything and then move everything function, and anything with the drawing logic I put in draw everything, and anything with moving logic I put in move everything, right? So that gives a little structure to the code and makes it better readable. And one thing which this now allows to do is to define a kind of a delay for the movement, and say, okay, whenever the frame count, the frame count is it's just a counter, basically counting how often this draw method has already been called, right? So I just yeah, I show you exactly what it is actually. So let me show you what the frame count is. You can see here, if I log the frame count, it basically gets up and counts how often, like each time the draw method gets executed, the frame count gets one up, right? So whenever the frame counts modulo the move delay is 0, so that means every 5th time in that case, only then we will call the move everything function. So what that does is that we do not call the movement in every execution of the draw method, and this makes the movements a bit slower. So that's just an idea. Of course, you can do what you want here. You can leave it as you want. You can make it very slow, or just leave it at 1. So with 1 we have the original speed, so to say. So yeah, have I forgotten something? I don't think so. So yeah, play around with that. I think that's really nice to watch at. Actually, let me aha. And now we need a move delay. So you see, you can play around a lot here. Maybe it's a bit too much. Sorry, that's not the right thing here. Okay, you see, you can play around a lot here. And yeah, I hope you had fun with this little video and this simple code creating really nice stuff. See you soon. Ciao, ciao.